Case number 3 is what we call an explosion, right? The first note on case number 3, it is the reverse of case 2, right? That means they are together before and they are separate after. So maybe they are linked by a couple or a spring vibe that you got going on there. That's object A and that's object B. Now there could be a range of things. These things could be standing still or they could be moving. So let's assume they're standing still right now and it's a compressed spring, right? So this again is my before, and it doesn't have to be like that. It can be anything. And this is my after. After, we have A goes in that direction, the spring is released, and B goes in this direction. Okay. So now there's some velocity. It's either moving or it's not moving, right? It could be moving in this direction if we assume that there is a velocity, and that's just V initial of the whole thing together. And this thing over here is just going to be VB, and this will be VA, and all of these will be final, right? Because it's happening afterwards. Now let's put together some kind of formula for this thing. Now when we solve problems in which we study, or we make this whole thing our system, right? We will study that system and this system, and we see that there's no changes, and that's the part of the world that we will isolate in order to study it. So let's see, it's going to be P before is equal to P after. So what does the P before look like? Well, it's going to be one mass of the two objects combined, which is MA plus MB, multiplied by V initial, because there's only one initial velocity. Now we say on the other side, I've got MV plus MV. I fill in A, fill in B, B, and that's the final velocity of B and final velocity of A. Now literally, it's the reverse of case 2. Can you see there? I've got that side, it's moved to that side, and I've got this thing, I've moved to that, and I've just switched around initial and final velocities. Okay. So recap on the cases. Case 1 is separate before, separate after. Make sure you've got this down and you've taken down the formula that we use. And then case number 2 is a collision, separate before, but they couple and they move off together. And then case number 3, and obviously you can see case number 2's formula over there. Case number 3 is where we've got them together before, but they break away, they explode, right? Whether they're connected by a spring or whether it's some rocket that breaks off into two parts, we find that this is case number 3. What you need to remember is together before, but they are separate after. And that is the formula that we've got over there. Okay, so I'm going to take this off the screen quickly, and then you can revise and see that you've got all of that in your notes. So there's my case number 1. These should be MA and MB, and because that's what I've done with the formula here. Double check that you have the correct formula. Is MV AA initial, BB initial, AA final, and BB final. And then we've got case number 2. We have got something here, and I've got a stationary vehicle there. They knock into one another, and then they move off together. So they've separate before, but together after, where the mass becomes one and they move off with the same velocity. And then case number 3 is explosions. They move together before and then they separate. So together before, the two masses are combined. That's why I have one mass. And then there's one velocity of V of A plus B. In other words, mass A plus mass B. Not V of A plus V of B. That's something else. And then at the end, they've got separate velocities. Okay, there's MV, MV, and therefore the momenta is calculated separately.